Hello again. In this lesson we will be talking about the graphs of trigonometric functions, specifically the graphs of the sine, cosine, and tangent functions. To start off, let's return to the unit circle. In the last lesson, we learned that the sine and cosine functions are functions of theta, which is an angle off the horizontal of a line which intersects the circle at some point, the point A. The sine function gives us the y-coordinate of that point, and the cosine gives us the x-coordinate of that point. Let's look at the sine graph first. So, why does it have this weird wavy shape? Well, it's because if you imagine changing this angle, then the height of this point will go up, and then it will go down again, and then it'll come back around, and it's going to repeat. And that's exactly the pattern we see on our graph. Here are some important points marked in terms of radians. You can see that at pi over 2 radians, our point is at 1. It reaches its highest point, and that's confirmed by our image of the height of the point, as at pi over 2 radians, there it is at 1. Next, at pi, it goes back down to 0. Here it is at 0 at pi radians. Then at 3 pi over 2, it goes down to -1. And at 2 pi, it returns back to its original position, and the cycle repeats. Now, the cosine function is much similar to the sine function, but it is shifted by 90 degrees over to the left or to the right. It doesn't really matter. This is because if you can see, the circle has rotational symmetry about the origin. If you look at the circle this way around, or if you turn your head 90 degrees, it'll look exactly the same, except we start at 0 with the cosine function. Except with the cosine function, we start over here at 1, and then we go down to 0, and then we go to -1, and then to 0 again, and then back to 1. This is confirmed on our graph. Here we start at 1, then go to pi over 2 radians at 0, then we go back to -1 over at pi radians, then back to 0, and return to 1. Here we have the two functions overlaid, so you can better see the differences between the two. You can see the cosine graph is shifted by pi over 2 radians from the sine graph. At pi over 2, the cosine graph crosses the x-axis at 0, while the sine graph is at 1. At pi, kind of the opposite happens, but the cosine graph is at -1, and we keep going, and we see this pattern reoccurring. Here's a little animation that might help you visualize what's going on in these graphs a bit better. You can see the cosine graph being drawn by the dot representing the x-coordinate of this point in the circle, and the y-coordinate of this point drawing the sine graph. Now let's take a look at the tangent graph. The tangent is a bit different from the other two in the way that it has asymptotes, but it still manifests this repeating pattern that we've seen before. Let me explain why this is so. We know that tangent is equal to sine over cosine, and if we go back to the graph, to this graph, we can see that cosine equals 0 at pi over 2, then 3 pi over 2, and then 5 pi over 2, which is the same coordinates as the asymptotes for our tangent graph. And we know that if we divide by 0 on a graph, then we have an asymptote. So there we go. That's why we have asymptotes on the tangent graph. Now, all of these graphs have a property called periodicity, meaning that there's a pattern of this function that repeats forever. The period of such a function is the length of one such pattern. It's one cycle. Formally, it is written like this, that for a function with period p, we know that f of x is equal to f of x plus p. Periods of sine and cosine are both 2 pi, as you could see from the graphs, but tangent only has a period of pi. Now, since the cosine and sine functions are waves, they have a property called amplitude, as all waves do. And the amplitude is sort of the height of the wave. This height is not the height of the entire graph. It's just the height from the middle of the graph upwards. So for general function f of x, its amplitude is the difference between the maximum and the minimum value, but halved, as we're not interested in the entire height of the graph, just half of it. The amplitudes of sine and cosine are both 1, as the unit circle has a radius of 1, meaning that no point on it can be further than 1 from the origin. The amplitude of tangent is undefined, as it has asymptotes which go to infinity.